Excellent. Thanks, Max. Appreciate the welcome and appreciate the opportunity to present to your user group this evening. So for everyone, just to level set, today we're going to talk about infrastructure as code, specifically around Terraform. This is the first presentation in a three-part series using Terraform. So today we're going to talk about the basics of the language. We're going to compare it to ARM and how that kind of relates or doesn't relate or compare. We're going to get to the basics of using the language as well as a demo of actual execution to see how that workflow works in comparison to other tools that we're used to. And we're also going to provide some other information as well. So as Max said, my name is Aidan Ermy. I work for Microsoft as a cloud solution architect, specializing in Azure infrastructure, which includes all the goodness of infrastructure as code. So here's what we're going to talk about today. We're first going to start with a level set of the benefits, excuse me, benefits and the tools available for infrastructure as cloud. Because this user group obviously is geared around DevOps, we don't have to spend a lot of time on that because you definitely are familiar and aware with that, but we're just going to level set quickly there. Then we're going to dive into what Terraform is and why people like or love to use it, considering the basics of the language to understand how we work with it, the different components that make up the language and how we use it. We'll do that comparison and provide some best practices in utilizing and using Terraform for your infrastructure as code purposes. And finally, we're going to provide some resources at the end for learning and certification because everyone has a lot of interest around that going forward. So how I like to present and go about these presentations is obviously I'm going to present some information. We're going to have that kind of dialogue, but feel free to put questions in the chat. I have that on a second monitor so I can try to keep an eye on that as well. If there's a question that I don't see, Max, feel free to chime in and call it out for me, or even if you are the person that has the question, feel free to come off mute and ask it so we can have a dialogue based on the topic that's being presented on the slide. But I will also stay afterwards at the end of the presentation for any additional follow-up questions that maybe we didn't answer or that you didn't get to ask. Okay. Okay, so first, quick level set on the benefits of infrastructure as code for everyone. Being a DevOps user group, like I said, you're aware of this, so we get that repeatable, reproducible environment, right? We have templates that are consistent in our deployment. We use variables, right, to kind of change that. That's where automation comes in. Our whole CI/CD process comes in. We get that auditability, that trackability using source control like GitHub or others like that, part of our kind of workflow. But the one piece we're going to call out specifically on the right side is it's not quite the same for configuration. Now, a lot of people, if they're just getting used to infrastructure as code or even Terraform in general, might kind of think that we can use Terraform for that infrastructure piece as well as the configuration. And we'll actually get into that as to why that's not the best practice or the best approach. But when we talk about infrastructure as code, it's really that infrastructure layer, the services that you're deploying versus the configuration of them, say, within inside a virtual machine, for example. So we can deploy the networking and the virtual machines and scale sets and all that other good stuff, but it's not specifically going to be used for the configuration inside of the environment itself. So just a quick point about some tools. No doubt this user group is aware of Visual Studio and Visual Studio Code, but those are the two primary tools that you can use with this. I like to use VS Code myself. It's really lightweight and easy to work with, especially if you're not doing full, deeper development and it's more just authoring the template files and you're kind of working with that. I like that interface a little bit easier, a little bit cleaner to work through. If you're going to use that product, I have two recommendations.
Hello?
Yep.
There's a lot of static.
Is there? Okay. Shouldn't be on my end.
And
Yeah,
again,
it's not
the
on your end.
static.
Max, that's specific to you.
I'm not hearing any static.
Okay, thank you. I'm using a hardline everything, so.
And
Okay.
it's you, Adin. Adin,
Is it? Can anyone else confirm?
something is wrong. Can you check, please?
It sounds great on my side.
Sounds
Yeah,
great to me too.
clear over here.
All clear here.
Okay. Did you want me to maybe rejoin, perhaps? Or if it sounds okay for everyone, I can.
I'm sorry, it's again. Can you hear something?
I cannot. Does anyone else hear anything?
Every time you say something, it's a static noise for some reason. Is anybody else hearing this? Or is it just me?
I think it's just you.
Yeah, everyone else says it's okay. It sounds good. So it might be on your receiving side. Okay. I'll take that we can. I don't hear any static when Max speaks, but I don't hear him super clearly either. I don't know if that's just on my side though. Okay, so I guess if the sound is okay, the majority, then we'll continue, and then if there's still an issue, we can maybe can drop and rejoin and see if that fixes it.
No, I think it was
Okay.
me. Sorry.
What's that? Sorry?
I think it was me. My apologies.
That's okay. That's okay, Max. It's all good. Okay, so let's rewind a little bit. So we're talking about VS Code. Just two extensions that I recommend when using, when you want to work with Terraform in this is the Azure Terraform extension by Microsoft. It has some Azure specific stuff with that. But the second one, it's Terraform, creatively named as such, originally created by Mikhail, but it's now owned by HashiCorp. And it's actually really nice, this extension, because it provides us a lot of intelligence when we're writing our templates. It starts to auto-complete default properties in. It tells you what properties are required versus optional. So that's a really nice extension. Now, HashiCorp has taken over ownership from Mikhail, and so they're starting to just iterate on that, build a language server into that to bring us some of those nice features. There's some things that are not yet in that extension, so there are some gaps. Just be aware of that if you're going to use it. But I am very excited to see where HashiCorp will take that to bring it to full completion, and we'll have some really nice features in that extension to make it easier to work with Terraform. Okay, so now let's talk about what Terraform is. In a nutshell, it's a templating language. So if you're used to various other clouds, like Azure has ARM, Azure Resource Manager, AWS has Cloud Foundation, Google has something that I don't know, right? There's other templating languages out there, but this is built in or on Golang, and it's used to be able to provision resources across different entities, right? So not only does it is it available to use in the public cloud across different clouds, which is a pretty common use case where customers or organizations want to be multi-cloud, but it's also able to be used like on-prem against VMware, against networking systems and so forth. Lots of really good flexibility, and why a lot of organizations tend to use Terraform, even if there are going to be in a single cloud to begin with, say like Azure, of course. If they want to have that flexibility to say, I might go multi-cloud in the future, then they might choose to use Terraform to begin with, so they're already in that kind of process or in that space already. Now, we're going to talk about the state file in a little bit more detail later, but that's a unique thing to Terraform in where it manages things, which we'll touch on. But I want to reiterate this last point. Terraform So you can think about other tools that we have out there that are purposefully designed and built to be configuration tools, like PowerShell DSC, like Chef, Puppet, Ansible, things like these. And people will ask, well, why can't I use, say, Ansible to do both? I had a customer that literally said, well, I'm going to use Ansible to get me 80% of the way there, and then I'll just script the rest. Well, that's not true DevOps. That's not that idempotent or reusability process that we're used to in a templating language and in a real CI/CD process. So that's why I have that awesome picture of a spork or a spork, depending on where you're from. You might call it one or the other. And it's there to highlight that you want to choose the tool that's right for the job. So with the spork, can you use it as a fork? Yes. Can you use it as a spoon? Also, yes. But does it do both of those jobs well? I beg to differ, no. So it's better to choose the tool that's specifically designed for what you're trying to achieve. So Terraform is designed as infrastructure provisioning versus something like Chef or PowerShell DSC for configuration control. So use the best of both worlds versus maybe trying to find one tool that does both sides, but maybe not fully or completely. Okay, any questions? Yeah, someone sent me a private message and I'll reply in a moment, no problem. Oh, there's a question from Dave. How does Terraform stack up against Cloud Foundation, SaltStack, GCP Deployment Manager? Like to see a side-by-side comparison. Yep, good question for sure. I personally don't have experience currently just yet with Cloud Formation. I'm aware of SaltStack and GCP, so I don't have a real-world comparison myself, but that's definitely an excellent question. Maybe I can do a follow-up on that for you. Later in the presentation, we will do that comparison between Terraform and ARM side by side, so that will at least help give you a little bit of context there and maybe help that relate to what you're familiar with Cloud Formation or other templating tools. But excellent question, thank you. So why do people love or like, depending, Terraform? Well, kind of like what we already shared in the previous slide, right? Because Terraform has this large ecosystem of providers that you can target your templates for deployment. Not only are there's the major clouds, but the lesser major clouds. There's on-prem security systems, there's networking systems, there's source control systems, Active Directory, Azure Stack, Kubernetes, all this other good stuff you can target using Terraform. So lots of flexibility around this. And in the whole infrastructure as code DevOps model, it's declarative, right? You have version control of your templates. You make a change, you know it was changed by who and when, and you can kind of see that progression. So let's get into the basics of the language. How does Terraform work? First and foremost, there's 4 primary commands that you want to be aware of with Terraform. Now, there's many other ones that we're not going to touch on. Some of them we cover more in the intermediate presentation that we'll do at a later date for this user group that gets into some of the more intermediate stuff. But the 4 primary ones you want to be aware of is first Terraform init, short for initialization. So this is initializing the current directory that you're sitting at from a command line perspective to initialize Terraform, for it to go and check for dependencies, for it to check for modules and everything it needs based on the template you've written, and basically prepare itself to be able to execute your template. Terraform plan is now going to read your template file. It's going to validate it or check it against its state file, what it knows to be real world, and compare the two and say, okay, well, this is what I know what's supposed to be in the real world. This is what you're telling me you want. What's the difference? Do I need to create something? Do I need to modify an existing resource? Do I need to destroy something in order to create something new? That's what Terraform plan does. It will come back, we'll see in the demo, it comes back and it will show you everything it's going to do, what it's going to add, what it's going to change, and so forth. Terraform apply is now we're taking that plan and we're saying, make it so, right? Go ahead, number one, if you're a Star Trek fan. We're taking the template and we're actually going to execute it. So Terraform takes the template, depending on what you're targeting. If you're targeting a public cloud like Azure or AWS or another cloud, it will communicate with the APIs of that and the cloud native language. So in the case of Azure, it's ARM, and passes that through to create the resources in the cloud. When it's done, it will have a very similar output back to the interface showing you what it created or changed or modified. Similar to the plan, but it's now showing what it's done and any output from the template as far as variables at creation time, like storage access keys or strings or URLs and database connections and stuff like that. You can ask for that back as output, and that will come back to you in the command line. Terraform destroy, kind of self-explanatory, obviously. It's going to remove all the resources, but specific to the template you're executing against. So if you have more than one Terraform template in more than one directory, Terraform destroy is only kind of narrowly focused in the directory that you're sitting. It's not going to go into another directory without getting into complications like modules and more intermediate stuff, and delete or destroy the resources specific to that template. So I see there's a question about, is plan like a syntax check? Good question. Yeah, similar like that, but there's a couple different layers or levels to it, and there's some additional things that it doesn't do that we'll also touch on later for how we can take it to the next level and even further enhance it. Yeah. Yes, so Dave asked if we're going to see code snippets. Yep, and we're actually going to see those in the slides, and we're actually going to see them live as well. So first and foremost, here's the basics of resource creation in Terraform. The first piece is that resource type. So you're declaring and saying, I want to deploy this, in this case, an Azure resource, so it's Azure RM, and then specifically within Azure, what resource type? It's a resource group in this example. The next piece is the name. Now this piece is internal to Terraform, how it can reference it. So think about like modules or functions where you call something and you're passing information or you're retrieving information back, kind of a similar context that's specific to Terraform, and the name, like you see in the example, does not have to match the name within the actual configuration property, even though it does in this screenshot example. So the name on the resource line is a way that you can refer back to it for properties within it. And then within the actual resource block, we have the configuration and the details specific to that resource. Just keeping an eye on the chat. Okay. So here's the Terraform file structure, and we're going to go through each of these blocks or chunks individually to kind of break it down to help you understand what's important to be aware of, to keep in mind, especially if you're just starting out with Terraform, and also if you're inheriting a project that was already started with Terraform. So the first piece is what's called a Terraform backend. This block tells Terraform a couple different things. First and foremost, it tells it what version of Terraform you're targeting. And that's important. If you don't have that line, it will assume the latest version. And why that's important is when HashiCorp released and was working on Terraform up to version 11.x, that was fine. When they released version 12, that was considered a breaking change. There were some fundamental enhancements and changes that they did to the language and the engine. And so when you're working in Terraform code, that's in version 11, if you were to apply this using Terraform version 12, you could never go back to version 11. It changes it. So it's important to think about that when you're working as a team, especially. Everyone wants to be or needs to be on the same version of Terraform to be able to not run into that issue where someone accidentally uses a newer version that's been tested, and then it causes issues for the rest of the team. The same principle applies between version 12 and version 13, though not as largely breaking or changing. Version 13 is another upgrade that you're going to want to shift to, and then do this required version kind of called version pinning, so that at least the execution will look for at least version 13 or newer to execute against. So there's a question about what IDE is the best for HCL debugging. Like I said, personally, I like VS Code because it's simple and easy to work with. Like you have obviously the terminal right there to kind of dig into and flip between what's happening on the console side versus the terminal side. That's my personal preference, but if you're used to other tools, then that's more maybe of a personal choice. The next section here is what we call the back end. This is telling Terraform where to store its state file. Now, the state file, which we'll touch on next, is where Terraform keeps track of what it knows to be the real world. That's what it checks against when it does its Terraform plan and Terraform apply. The back end can be many different things. You can store that in Azure, like in a storage account, or Amazon S3 bucket, using third-party systems like Artifactory or Console. There's lots of flexibility there, but you're going to want to ensure everyone is pointing to the same state file because that's the source of truth, right? And you're going to want to protect that as well, which we'll get into in a moment, which is right now. Note the really hard to read square in the top right corner. I made it really eyesore so it would grab your attention. The state file, when you're executing your Terraform templates, will contain usernames and passwords and keys and tokens. You need to not only store this in a remote location so that if you're executing locally, you're not losing the file, and then other people can work with it. But then you also want to include things like RBAC and control over who can actually access that state file because it has that sensitive data in it. So that's something that's unique to Terraform. I don't know about AWS for Cloud Foundation, but I know from an Azure perspective, Azure RM or ARM does not have a state file. But you can look into the state file and be able to see those outputs from those resources that you create to see what the actual values were at creation time. So if you have like a naming convention for the resources that are dynamically or randomly generated, you can be able to traverse the state file to be able to read that, or get that as an output from the state as part of the template execution. Yeah. Okay, the next section is the provider section. Now notice here, we're telling it, okay, we're targeting Azure. What's the API effectively that we're going to leverage? This case, Azure, AWS, GCP, whomever. Notice we also have this version reference here too. Same principle applies to the Terraform version pinning as it does to the provider version pinning. Reason being, when Azure, when Microsoft, when we released the latest version of the Azure RM provider for 2.0, again, that was a major change. So there were some breaking changes and some issues potentially from an older version. So you want to get into the habit as a best practice to use that version pinning also for the provider reference. So in like a CI/CD process, you're going to want to maybe even be more explicit and not just say anything above 2.0. Maybe be targeting a very specific version, and then as a new version is released, you're able to test it against something new, and then everyone can change their code to be able to target and use the latest version. Sorry, is there a question? I think I hear someone off mute. Nope. Okay. So the other piece of the provider block, you can provide these as like environment variables. You can provide them in like a pipeline variable as well, which I actually demonstrate in the advanced series of this, doing a full end-to-end DevOps pipeline with this. You can pass in subscriptions and the SPN ID and password and tenant as part of that Terraform execution. It's not required, but it gives you lots of flexibility in telling it where it's going to specifically target and communicate with. The next thing is the variables block. So if we're developers and DevOps, we all understand variables, right? How those kind of work. Very similar in Terraform. We tell it what type it is. We can give it a default value. We can even provide a list of allowed values so that we can restrict where things are being deployed. So a good example is location, and maybe our customers have a geo requirement that everything needs to be in Canada. Okay, so you can restrict this location variable to only accept Canada Central and Canada East as a valid location. In version 13 of Terraform, which is now out, there's an additional enhancement for variables where you can actually build conditional logic checks for the variable itself to validate it as part of the input, which is pretty cool. Notice in the screenshot as well, we're able to reference that variable directly, right? So we're referencing the variable for the resource group name and the location variable that we're passing through, and we'll see this live as well. But when it comes to variables, note the blue box here that they have an order of operations when you're submitting them. And you can work with different files. You can put them embedded with more often have a separate TFR file so that you can encapsulate all the variables specific to what you're deploying. So a good example that I did for a customer is they're deploying a global networking infrastructure in Azure across multiple Azure regions. They're peering and all this good stuff. For the networking templates, we would take the templates and we would have a separate TF vars file for all the properties specific to the region that we're targeting. So Canada Central had a specific like CIDR range, right? The subnets had certain CIDR ranges and so forth. And we would use that vars file along with the execution of the template to make that unique deployment. Then all we have to do is make a new TFVARS file for Canada East and repeat the exact same deployment and just change the applicable values that we're passing in. Personally, that's what I see the most used, even though you can use other things like environment variables and so forth. If you put it in TFVARS, you can include that in your source control, right? That might be a little sensitive depending on what data points you're putting in there, but still an option to consider. Okay, now we're going to talk about dependencies. Similar to kind of like in programming, right? There's interrelationships of resources. So in our example here, there's two types of dependencies in Terraform. One is implicit and one is explicit. So implicit, it implies that this, resource A or resource B rather requires resource A to finish before it can execute. So in our example, we're saying, because we're referencing the resource group example .location for the storage account, Terraform understands that, hey, well, I need this resource group resource to finish being created first to be able to get the value of its location, to be able to pass into this parameter or this property for this storage account. So it will understand that. Now, if there are dependencies, but there's no resource references or property references, and you want to control kind of the daisy chain or order of operations to execute, you can use the depends on argument as well. You can put depends on and reference that other resource so that Terraform will understand, okay, I need to wait for that one to finish first before I can move on to this other one. A good example that I used in the real world for that would be that networking scenario, but VNet peering. So as part of the pipeline to deploy the templates and deploy a core VNet and a prod VNet and a non-prod VNet and then do this mesh peering, you can only execute a VNet peering in Azure one at a time. You have to wait for the operation to finish before you can do another one. They can't happen in parallel. So really, VNet B has no dependency on VNet A being done its peering. But from a technological execution standpoint, it does. So putting a depends on for the peering resource object in the code allows me to control and say, VNet B, do not try to peer with the hub until it's done peering with VNet A. Hopefully that makes sense. As a bonus, version 13 is no longer in beta now, which is great, but we did not, up to that point, have the option to use depends on within modules. Now, modules are a little bit more of an intermediate topic, which we cover in the next session of this, but it was really painful being able to kind of encapsulate our code in more repeatable blocks and chunks and just call them kind of like a function without being able to have a depends on to kind of do that proper daisy chaining. It was rather difficult. So now, thankfully, we have that support within modules with version 13. Okay, finally, let's talk about output. We've created our template. We have our properties, our variables. Things are, depending on each other to execute. And now when it's all done, we need information back. In this case, I want, say, a resource group name. I want a VNet name, or more importantly, a VNet ID, because I need that actual real world property, the value, as part of some other execution. So when we talk about modules or daisy chaining, if you want to be able to use a value of something you create through Terraform, like your storage account access key, like your database connection string, anything like that, you need to declare it as an output in your template so that that property value is returned back to you and then accessible through for other execution. So Dave's got a question about if I were to design and implement a self-service infrastructure portal, would its hardcore provisioning limits, like max number of instances, be managed through Terraform or via Azure AWS provisioning policies? Yeah, that's a good question. That's complicated because creating a full self-service portal on top of an already existing portal is rather difficult, right? Because you want to, is the question that you want to be able to limit and prevent people from, say, deploying more than 10 EC2 instances? Okay. Yeah, so that would probably, Terraform doesn't necessarily account for, hey, how many of these am I allowed to deploy? It doesn't really care about that. But that's where things like in Azure policy might come in, or on the HashiCorp side, using something like HashiCorp Sentinel, which can do an assessment on how much are your resources going to cost, for example, and then you can have a rule wrapped around that to say, you know, if someone's trying to deploy something that costs more than $100, stop the deployment, like prevent it from actually executing the Terraform template. Can outputs be referenced in different accounts? Yes, that's more on the intermediate side that we cover a little bit, but that comes into like remote state reference, that you can effectively reach into another state store, provided you have permissions, of course, and be able to pull out the value that you want, the property value that you want from that to be used in some other template. Yeah. Okay. All right. So let's stop talking and let's go to the code. So if you can just confirm that you can still see my screen, you see the code, correct?
Looking good.
Awesome. Thank you. So we did the cooking show because normally I would start with a blank template and start typing it out, but I want to kind of just highlight a few of the key differences around version 13 as well. So one thing we didn't show is new to version 13 is this required providers block. And it can be a little confusing because if I just close this for a moment, you'll notice in the Terraform block, I'm calling the Azure RM provider here, but I still also have a provider block for the Azure RM providers. So can you combine those two? Yes and no. The required providers, right, is telling you're telling your code where I am authorizing the source to come from. By default, it's going to go to HashiCorp, right? Because it's the HashiCorp product and it trusts HashiCorp. But if you wanted to target like a third-party repo for a third-party provider that's not hosted on the HashiCorp site, here's where you can tell it this is where it is, and also what version you want to do that pinning to. So notice in the required providers block, we're doing the version pinning here, but in the provider block, we are not. I have commented it out. Now, there's another feature set within the provider block called features, ironically, that you can override or control the behavior of specific resources. So the reason why we still need this provider block is these properties underneath, and also if we were to reference a specific subscription and so forth, cannot be a part of this specific block under Terraform. So they're not, they're a little bit melded together because we have the version reference that comes up to here, but the rest of this does not. So here you can actually control, if I deploy a key vault, by default, you know, it has soft delete on there. You can override that. Same thing with doing virtual machines and the scale sets. By default, it won't delete the OS disk when you do Terraform destroy. You can override that native behavior within the code so that it will execute as you expect, and you're not left with, say, orphaned objects and items that possibly are costing you money. Further down here, we have our location variable, right? So we're giving it a specific location and description. We don't have any of the conditional logic around there, but that's something, if you're expecting like a naming standard parameter type of thing, you can kind of build that out. So there's a little bit better of a user experience so that when they're executing your template, and maybe they're not familiar with Terraform, they are getting a message back saying, oh, we're expecting this. So they know they're going to provide the right parameter, the right value, or the right way that the variable is looking for. We have our resource group here. Sorry, there's a question. So Terraform required providers allows us to define what provider code version you want. Right up here. While the provider block itself allows us to set parameters for the provider. Right, that is correct. That is chosen. Yeah. So here we're controlling further effectively like features or properties of the provider itself, and also in this case Azure, where we want it to connect to. Whereas up here we're saying this is the version of the provider we want. We cannot define any of these customizations in the provider in this required providers block. That's correct. Yeah.
I got a quick question. Sorry.
Sure.
Can you nest the files one into another, or like have a section on variables that you can collapse? Because I'm thinking if I have 50 variables, that the file becomes really long. It becomes
really long.
It becomes difficult to manage, right?
Yep, absolutely. So yeah, good point, Max. Thanks. So I get more into that in the intermediate side, but absolutely, from a project organization structure, absolutely recommend dividing pieces out. So as an example, you would have a directory and you could have multiple Terraform files in there. So this blank one could say variables.tf, this one could be outputs.tf, and then this is your core code. And then what Terraform does, as long as it's all within the same directory that you're executing, Terraform takes all those files and basically merges or squishes them all together as if they're one file. But from a human standpoint, it allows us to have that separation of code to know, okay, variables are over here, outputs are over there, and you can iterate and work with that a little bit more easily. Absolutely. Yeah, that's exactly the recommended approach. So we have our resource group here. Give it a name. Hopefully that's not too long. I changed it. We'll see. And this is the name, the Terraform object reference, effectively, that we're calling it. In our storage account, notice we are saying resource group. So this is the resource type, dot this specific name, dot this specific property. This is what we want to fill in for the storage account and also the location specific to it. Now, I've commented out tags to show you what Terraform does when you make a change to an existing resource to see how the output changes. And then down here, again, same thing. We have outputs. We need maybe our access key, our connection string, whatever property we need of the value after creation. We need that output listed so that we can now get it out and it'll be stored in the state file. We can access that and use that in another template somewhere else. Okay, so let's actually execute this. I'm going to make this a little bit bigger here. And we're going to start with Terraform init. So notice it initializes the back end. If I minimize this real quick, I do not have a back end configured here. I haven't set anything to say go store it in a storage account. So I'm using my local system directly in this context, just for simplicity of the demo to make it faster, that's all. Then it says, okay, you're using the Azure RM provider from HashiCorp, and you say it has to be at least version 2. What's the latest version that matches that criteria? 2.36. Awesome. And it goes and pulls it down, and now it's ready to go. Notice after Terraform init, we have this .terraform directory ready to go. This is what's created as it pulls down those various plugins. Oops, and then my screen goes a little wonky that way. So then we go Terraform plan. It reads our template file. It reads the state file, which did not exist before because we're using it locally. Here's that Terraform state file that it created automatically because it's local, right? And we see, if we scroll back up to the top, green means go, means I'm creating something brand new. Here's what I'm generating. So notice some of the properties, of course, we only know them after the object is created, like IDs and so forth. But also notice if we look in our storage account as it's prepping, if I can find the right property, location, which we had referenced as a variable of the resource group, is Canada Central because it's pulling it from this one right here. Same thing down here somewhere alphabetically for resource group name right here. It's pulling it from that specific resource. And then all the other stuff is kind of like stuff that's created by default that we have not declared. All right, and we're going to create two things and not change or destroy anything. So we're going to go Terraform apply, and I'm going to make it a little bit faster to say auto approve. Reason why I'm going to do that is if you just do Terraform apply, you're going to get all of this exact same output from Terraform plan, and then it's going to sit there and it's going to wait. It's going to say, are you sure you want to do what you just told me to do, yes or no? And you literally have to type yes, enter for it to execute. So think about this from like in the advanced series from like a DevOps perspective, right? In a pipeline, you don't want Terraform execution to sit there and wait for human input as part of a pipeline. That'll just break the whole CI/CD model, right? So there's a question of would it show replacement as well? Replacement of what? Sorry, Hardeep, I'm not sure what you're referring to. Oh, sorry, I see your other thing. Can outputs be referenced in different accounts? Oh no, we already talked about that.
No, by replacement, I mean, you know how if something is getting created right now, we just saw you said it's highlighted in green.
Yep.
But sometimes it gets replaced, right? Or
Yep.
Some instance get destroyed or recreated.
Absolutely.
Right? Did it show that as well as a warning before we actually deploy it?
Absolutely. Excellent question. And it absolutely will. I believe I demo that possibly in the intermediate one. I'm not too sure, but absolutely correct. So what we'll do is we'll see that this is created. Notice here's all of my outputs, right? I got my access keys. Please don't hack my account, or my connection strings, all that good stuff. We can leverage that for like an app connection or whatever we need. We can reference this value. If we go to the portal and I do a refresh, and then here's our storage account, and we don't have any tags on it right now. Okay, great. If we go back to our template, and we're going to uncomment our tag block, and then we're going to rerun this. So let me just fix this so it's clearer. There we go, Terraform plan. So we're going to do Terraform plan. It's going to read the template, compare to what it knows in the state file as real world, and it's going to see a difference. So you'll see it's reading from the actual values from the state file. And now it's going to come back and say, hey, wait a minute, you changed something, right? So it will highlight in this little kind of yellow squiggly, that might be a little hard to see, sorry. A little yellow squiggly saying, this is what you're changing and this is what you're adding or removing. Now, here's an important point, and thank you for bringing it up, Hardeep. When we're changing something, notice the yellow squiggly means update in place. Depending on what you're changing, like what property, that is not always the case, right? So maybe you're changing a value. Let's take a storage account as an example. If you deploy a storage account as LRS, local redundant storage, and you're like, oh, wait a minute, that was supposed to be geo-redundant, and you change that property, currently today, Azure does not let you change between those two storage replication types. So what Terraform will show you is it's going to say, oh, you changed this value, but I actually need to destroy the existing resource in order to create a new one to be able to align to what you're telling me you want, because I cannot change that value in place. Azure or AWS or whatever does not allow that for that specific resource type or that specific property. So excellent question. So Jason asked, does Terraform handle out-of-band changes? So if someone manually modifies a resource that's supposed to be managed by Terraform, of course, will the system detect and revert those changes? Excellent question, Jason. I cover some of that in intermediate, but I actually recorded a separate video and put it on my YouTube channel about state management in Terraform and comparing two scenarios that involve just that. So the first scenario is I create a resource and then someone goes and changes it manually in the portal. What happens? Like, because now that's not real world, something breaks. Or like the reverse, right? Where I create a resource in the portal manually instead of Terraform. How do I bring that under Terraform management? So that's on my YouTube channel. It's not too long. It's like 20 minutes. But effectively, what will happen is Terraform thinks it's real world. So if the resource that's deployed does not match what Terraform sees in its state file, it will overwrite those changes. So that's a key point for any of our customers that are working or starting to go down the DevOps route, and especially the infrastructure as code. Once you move in that direction, especially with Terraform and the state file stuff, you have to get, everyone has to be on board to do it all in the same way, or you're going to have challenges like that for sure. And it's either gonna be a very rude awakening where something is overwritten, or something is going to be like destroyed in production type of thing, and that's not going to be good. So everyone has to be on board from a people process mindset to understand, do not do it in the portal, right? If you're going to do Terraform and infrastructure as code. Now, you might ask, well, what if it's like, production red alert, something, Sev A or Sev 1 critical situation, and we need to fix it manually right away. Well, if you go and do that in the portal or through a PowerShell script or something quick, so production is back in operation, you have to remember to go and implement whatever change or modification you did back into your Terraform template file and rerun Terraform plan and apply, because plan should say there's no change because now it does match what it should be, but it still needs to put it in a state file to remember what it should be. Yep, I will definitely share that YouTube link for you guys after, because that was a big ask for sure. So here, right, basically it's saying you're going to modify this. This is what you're going to add. If you're going to delete, I'm going to ignore this actually, and I'm going to go Terraform delete. Whoops, destroy. Auto approve. Same thing. If I can spell is it 1P or 2? I forget. Now I forget. Nope, it's obviously 2. And while I'm going to get out of this so I don't hang it up, and it's going to do the same type of thing. It's going to go and destroy what I've defined in the template specifically. Now, here's another thing I want to call out for Terraform destroy, especially for DevOps and CI/CD. I have that auto approve. Same thing with Terraform apply. If you don't have auto approve, it's going to sit there and wait and say, okay, here's what I'm going to destroy. Are you sure you want me to do this? Yes or no? And you have to type yes and enter for it to execute. That breaks our whole CI/CD model, right? So you're going to want to have auto approve in the command line for the execution, which I do cover in the third installment of this series for the Terraform DevOps presentation. So I'm going to let that run and bake because it's just going to clean that up, which is fine. And I'm going to go back here. And hopefully, of course, it does that instead of goes to that slide. And if everyone can say, yep, you can see it, yes, no? I think I can see it. I think it's good.
Looking good.
Awesome. Thank you. Okay, so let's kind of wrap things up while the Terraform stuff is cleaning up. Let's kind of do the peanut butter jelly time, like I call it, comparing ARM and Terraform. Do they mix? Do they not mix? Which one's better? It depends on your own personal opinion, I guess. So here's a quick feature comparison. I'm not going to go through every single one in this list because that's boring. You can read it yourself. You'll have access to the slides also available to you after with the various links that I have available and so forth. But basically, ARM is infrastructure as code, so is Terraform. ARM is JSON, Terraform is HCL, and so forth. Certain things Terraform had that we did not have in ARM, but we do now, right? We have what if, and I think what if is now out of preview. We have dependencies, but they're a little bit different in ARM versus Terraform. And of course, Terraform is designed for multi-cloud, whereas ARM, you're not going to use ARM to deploy something in AWS or GCP. From a configuration standpoint, even though it's not recommended to use Terraform for a configuration as code perspective, they have things called provisioners or other providers for that. I believe provisioners is going away. I think HashiCorp mentioned at their latest conference that construct is going away. But there's other providers. And what I mean by this is you can have a Terraform template to say, here's my virtual machine that I want to deploy. As part of that Terraform execution, you can have a provider say for Chef and say, after you've deployed the virtual machine, onboard this virtual machine to this specific Chef recipe and execute the configuration through Chef. So you can still kind of chain things together, but you're not controlling the actual configuration properties through Terraform. I love the question. The question is, so is Bicep Terraform for Azure? This is being recorded, so I have to be careful what I say. But Bicep is definitely a DSL language like Terraform for Azure, absolutely. When you look at it side by side, I don't have an example in this deck, but if there is interest, I can definitely kind of build another quick presentation or do a video recording for my YouTube channel for you to compare ARM, Bicep, and Terraform. I personally actually have worked with the ARM team inside Microsoft because of my experience with Terraform on Bicep. So I provided them a lot of input into what I like, what I don't like, what works well, what are some challenges, right, in comparison. And when I first saw Bicep, I had that exact thought. I'm like, hey, this is just Terraform, right? It looks similar. There are some differences, of course, but to each their own. The other thing you have to remember with Bicep is like ARM, there's no state file to manage. And that's one of the challenges, personally, with Terraform is if the state gets corrupted, that's all Terraform knows about the real world. If it gets corrupted, if it gets deleted or lost, then that's going to be a really big challenge because the next time you execute Terraform, it's going to think, hey, nothing exists. I need to recreate all of this. And then you're going to get into like conflicts for like naming for stuff that already exists, or like, you know, quotas depending on how large of an environment you're deploying and so forth. It gets really complicated, but there's pros and cons, right? It depends on what works best for you or for your customer, what works for them on what platform, right? Depending on what they're targeting. Next slide continues with this table. Again, I'm not going to read it all, but basically calling out things like that state file thing is the biggest difference, right? What you have deployed in Azure is effectively the state, whereas Terraform, you have to manage that file independently. And so how do you compartmentalize that depending on your execution? So a good example with that networking, that global networking project that I did, we built the templates for the hub and spoke network topology, so core, prod, and non-prod for each Azure region. So obviously the templates, just 3 templates, they're all the same, and a separate TF-vars file for each location that we're targeting. But we would have a separate state file for core networking Canada Central versus say core networking Canada East. That way we can roll something out in one area, and if it causes an issue, roll it back versus affecting a larger area all at once. So you think about state files and controlling the life cycle of the resources that go together and have that relationship. Make sense? Okay. We didn't talk too much. We talked a little bit about modules, but that's more in the intermediate one where we get into code reusability, referencing remote state, and those types of scenarios as well. So this is a little bit hard to see, so my apologies, but this gives you that side-by-side view between ARM on the left and Terraform on the right. So you'll see there's some similarities, but really at first glance, Terraform is a lot easier to read from a human standpoint, and that's the perspective, right? Machines don't care what code looks like, they just process it. But for us as humans to write it and to manage it, readability is definitely a factor. So it's a little bit cleaner and easier to read, whereas the ARM side is more XML type based, right? So if you were to put a bicep in between this or on either side, you would kind of see how similar it may look and feel to Terraform. Not completely the same, but similar type of structure. Okay, now let's share some key points of information. A lot of people will ask, hey, does Microsoft even care about Terraform? You have ARM, so why would you care about Terraform because it's a competitor? Well, let me kind of put it this way. If you're not aware, obviously HashiCorp has their team of developers for Terraform because that's their product. Microsoft also has a team of developers working together collaboratively with HashiCorp on the Azure RM provider. So Microsoft is absolutely invested in Terraform. We don't own the provider like solely. It's not just Microsoft authored, but we heavily contribute to it. So the point is, with the investments that Microsoft is making in Terraform for this provider, you see the latest update is supposed to be today. When we executed the code, it said it pulled down version 2.35. So I believe later tonight, 2.36 is going to drop. We do a release into updating the provider every week, maybe sometimes more, but ultimately we try to do it every week. And sorry, I forgot to change August to the former month. My apologies. But in this latest release, there's been 30 enhancements and bug fixes in it. So it's not just one or two things. There is active development from Microsoft investing in Terraform specifically for Azure. What we like to say is, if you think about ARM and how when we release a new feature or a new product or something, that's available in ARM day one, effectively. We are striving to make Terraform at the same level as ARM, what we call a first-class citizen. So effectively on par with ARM. We're not quite there yet, right? There's still lots of work to kind of catch up and get into to make it to that level, but that is ultimately the goal, so that as stuff is released, it is provided or available in the Azure provider for Terraform as quickly as possible. So absolutely, Microsoft loves Terraform and is definitely invested in supporting that. The Terraform module registry, we as Microsoft also contribute directly to those modules that are publicly available to be used as those snippets of code to deploy a scale set, deploy a virtual network, deploy whatever. Our team is contributing heavily to that as well, to build these battle-tested, real-world tested modules of reusability for you. So what about the roadmap? Because everyone asks about the roadmap, right? When is this coming? When is that coming? If you go to the GitHub repo for the Azure provider, you will see very publicly the milestones for what version is coming out, what is planned to come out for that as far as like the bug fixes and so forth. You can drill into it to see, okay, you see there's a breaking change for this. There's an update to documentation to that. Here's a new resource that we're providing because it's something new that we've released in Azure. There's an enhancement that we need to do, something for, like in this case for Azure Firewall for a property or something like that. This is all publicly accessible. So working with your customers and your clients, and maybe they come across something or you come across something that's not there yet, you can go here and effectively check and say, hey, look, yeah, actually that's going to be released next week, right? So you can use this as part of your future planning if your customer or yourselves are using Terraform, so that if there are gaps, you have at least an idea of roughly when something might become available. So you might have to come up with a workaround for now, but knowing that it's going to be in the provider within X period of time. Okay, let's give you some best practices so you do it right the first time, because nobody likes to do it again. Like we talked about, we definitely want to use remote backends. Even if you're a developer team of one, get into the habit of using remote backends. That way, if someone else comes on board, so now you're more than one person, or you're now part of a team, or you're handing it off to someone else, it's all seamless. It's stored in a central location. Maybe it's a storage account. It's being backed up. Maybe it's in Terraform Cloud, whatever. But use remote backends, even if you're just doing your own development yourself. Get familiar and comfortable with that so that when your customers ask you to do it, yep, no problem, I can make that work. Use version pinning for the version of Terraform, for the version of the provider, like we saw, and for modules. Now, we didn't cover that in this session. It's going to be in the next one. But basically, version pinning is your friend so that you don't accidentally run your code against a higher version that has a breaking change, or it's something where you go from version 12 to 13 or 13 to 14, and it's a breaking change and you can't go backwards, right? And now you've maybe caused a bit of a headache or a challenge for the rest of the team. Implicit dependencies make it a lot easier. You don't have to put in the depends on in every single resource. It's nice. You can use that depends on if you need to, right? Like we talked about, but implicit dependencies make your code cleaner, right? It's not as many lines, and you don't have to declare something that's automatic effectively for Terraform. Using modules, whether you're making your own custom modules or from the public repo that Microsoft and others contribute to, makes it a lot easier, right? If you say, I need to deploy a virtual network, here's our standard configuration, make that into a module. Then all you have to do is call it, pass the parameters it needs, wait for it to do its thing, and it returns those outputs, those values back to you, and then you can use that along the rest of your code. That's that reusability aspect that we'll touch on in our next presentation next time. And finally, if you're not aware, if there's a limitation in Terraform where the provider does not have a direct way to create a specific resource in Azure through Terraform itself, you can take an ARM template and embed it inside a Terraform template for deployment. But you lose some of the functionality of like the state reference and things like that. So only do that if you have no other choice or no other way to do so. It's a workaround option until the provider is updated with that feature or that specific resource, but know it's there at least, but ideally only use it when you really have to. Okay. Now let's get into just a couple of slides just for some learning resources for everyone, depending on where you are with your Terraform journey. So here's a question that a lot of people will ask, well, why not use Chef, Puppet, Ansible, SaltStack, CloudFormation, or with our executions, right? This first article link, excellent article that explains why this organization chose to use Terraform over these other ones. And this is the premise of that spork or spork scenario, right? Where use the tool that's purposely built and designed for its use versus using a tool that kind of does both but doesn't do either quite as well directly. There's labs you can get some hands-on to get some best practices, get some familiarity with working with Terraform code, right? We have our aka.ms Terraform Hub documentation for Terraform specific to Azure and our investments there in the provider. And also that last link is my personal curated list of learning resources. So as I've been learning and working with Terraform over the past several years, you know, if you know me personally, some of you do know me personally, I read a lot. So I read a ton of books, I read a lot of articles, watched a lot of videos, and did a bunch of courses. When you look for resources to learn something new, it's hard to know what is the best resource. This is my personal list of resources that I found most effective as I started to learn Terraform. So there's a mix of stuff in there that you can take a look at and see if that'll help you in your journey. Okay, two more slides, because I know we're running out of time, sorry. Certification. Because HashiCorp has released the Terraform certification, associate certification, everyone's been asking about it, right? And so myself and another MVP, Ned Bellavance, we co-authored a HashiCorp Terraform certified prep guide. So we wrote this before HashiCorp had their official learning study guides, but we also wrote it based off of our personal hands-on real-world experience with Terraform, relating that to the objectives of the certification. So that's up on LeanPub if you want to take a look at that. A lot of people have grabbed a copy and said it's been effective and really helpful for them to learn. So that's their opinion, which is great. But then also, of course, HashiCorp has their official learning resources now that the exam is no longer, say, in beta, for example. They have a study guide, they have an exam review, and also some sample questions. So those are definitely excellent resources that you can use to learn as well. So finally, this is my last slide. This is who I am. This is how you can contact me. This is some of the stuff that I do and what I specialize in. Before joining Microsoft, I was a 5-time MVP. HashiCorp has thankfully nicely awarded me with the HashiCorp Ambassador Award this year. It's kind of like the Microsoft MVP award, but for HashiCorp, which is nice. And here's where you can get a hold of me on my email. My YouTube channel is linked there. I have multiple repos in my GitHub that have Terraform examples that I use for today, as well as my two other presentations, the intermediate and the DevOps stuff as well is up there. Feel free to connect with me on Twitter or LinkedIn or reach out in any way. So with that, that is it. I'm gonna be quiet now for a moment, see if there's any questions or anything I didn't answer.
Thank you very much. It was good, excellent. Did somebody type up a question? No, it was just thank you. Anyway, anybody have any questions? No? All right. Again, thank you very much. Like I said before, it was great. Looking forward to the next one, which will be the next month. I forgot the date, but you can look it up on our Meetup website and go ahead and register. And I will see you next month. So thanks again, everybody. Have a good night.
Yep. Thank you, everyone.